I've been wanting to make this video for a long time. Every time I hear the word heavy soil, how it's usually used, it makes me cringe, and I just don't think it's a correctly used term to refer to soils. And I'm going to demonstrate in this PowerPoint why it is not the correctly used term. And like if I'm reviewing a paper and I see the term heavy clay soil, I just want to see them use fine clay soil or clay soil rather than the heavy adjective to describe it. So if you type it into Google, it says that heavy soils contain more clay and are sticky and hard to work, but are more fertile. I can make another talk on why clay soils are more fertile than coarser textured soils that are sandy, and why they retain more water, which keeps them cold and wet in the stream. It's actually from the water retention and behavior of water with the soil material, and not because of the weight of the material, why it behaves differently. And this Floridan says they have more clay and are sticky and hard to work, and that's because of the behavior of the material that they use. It has nothing to do with their weight. And they remain cold and wet, which is due to water retention, and things don't heat up as fast when they have a greater water content, because water content has a lot higher specific heat. Water has a lot higher specific heat than the soil minerals themselves or air, so it takes a lot more energy to heat up water compared to heat up air. And you can add sand to them or coarse organic material to admit air to them. And the false thing about this is clay soils actually have more pore space than sandy soils do. So here's another thing I don't like about this term, heavy soils. So the first thing I'm going to go into is the soil particle size class material. Coarse fragments like gravel, rocks, stones, boulders are greater than 2 millimeters in diameter. Sand is 0.05 to 2 millimeters. And silt is 0.0002 to 0.05 millimeters. And clay is characterized as less than 0.002 millimeters. But there are different types of minerals that make up most of these different fragments in the soil. So here's a soil textural triangle and like what percent of each separate you have, and you get how much sand, silt, and clay is in the soil by adding sodium hexametaphosphate to the soil and dispersing it. Then you sieve out the sand fraction of the soil on a sieve of 0.05 millimeters diameter. And then you use Stokes' law and how long particles take to settle out to determine what particles are less than 0.002 millimeters. And that's how you determine the particle size analysis of the soil to see whether it's a clay, sand, or silt, or whichever one of these other descriptors that you have of our textural classes. And here's things to determine soil weight. Bulk density, which is mass soil solids over total soil volume, which is essentially the same thing as specific gravity, and its units are generally grams per centimeters cubed. And particle density, which is mass soil solids over volume soil solids, which is that. And I'll have a triangle to show the difference between these two. And then dry unit weight is the mass of soil solids times gravity divided by the volume total. So it's essentially taking the bulk density times gravity. And that's how, like if you're loading a dump truck full of soil, you determine how much weight is contained in the truck. So that's how you can calculate that to get actually the weight. It's still depending upon the bulk density or specific gravity of the material. And here's the common particle density of the different soil materials. So organic matter, which is humus, which there's no really agreed upon structure of, it's just a bunch of organic compounds put together. So their particle density is really highly variable, is less than 1.5 grams per centimeter cubed. And most of the soil minerals are somewhere in the 2 to 2.8 grams per centimeter cubed, and most are around 2.65 grams per centimeter cubed. So the soil is generally assumed to be the particle density of quartz, which is 2.65 grams per centimeter cubed. And the sand fraction of the soil generally consists of quartz and some feldspars and micas, which you can see what the particle density range for them is. And the same thing with the silt fraction of the soil, but the clay fraction of the soil consists primarily of smectite, illite, and kaolinite, except in volcanic situations, which are the allophane and volcanic glass that I have listed, which is mostly around the Ring of Fire where you find that. So smectite is actually lighter than most of the quartz specimens. And the other soil clay minerals that are common are the same weight as quartz. And in like the Great Plains in western U.S., you have a lot of the smectite in your soil clay fraction, whereas in the southeast U.S., you have a lot of kaolinite in your soil clay fraction. So here's the soil material where you have part of the soil that's the solid. So when you calculate bulk density, you have the mass of the solids divided by the total volume of your soil, and particle density is mass of solids divided by volume of solids. So if you know the bulk density of the soil, you can determine the amount of pore space you have in it, or it's commonly just calculated by doing 1 minus the bulk density divided by particle density because of the relationship between the particle density and the bulk density, which is shown by this diagram. So in general, clayey soils have a lower bulk density than sandy soil. So like the average bulk density of a clay soil is like 1.1, 1.2, where the average bulk density of a sandy soil is like 1.5 or 1.6 grams per centimeter cubed. So actually per weight, a clayey soil is lighter than a sandy soil. And what you can do to your soils, you can do management practices to reduce bulk density, and they're basically just management besides the trafficking, they're also just practices to increase the organic matter, and organic matter is actually the lightest of the soil materials. Most soils generally have less than 5% organic matter unless they're a wetland soil. So what you can do is you can reduce trafficking on soil from driving your tractor over it, driving equipment and vehicles and other things over it, walking over it, and overgrazing it. You can add organic materials to the soil. You can reduce and minimize tillage, do conservation tillage practices where you reduce how much you disturb the soil, because when you till the soil, you add more air into it and it causes the organic matter to break down faster. And you can use practices such as leaving residue on the land or cover cropping or no tillage, which are just practices to promote soil carbon in your soil and promote structure and create having more pore space. So that's what you can do to reduce the bulk density to improve a soil if it is clayey. And here's why heavy soils is a misused term. The the plasticity and high water absorption, which they're referring to, is due to the behavior of the clay fraction of the soil. It has nothing to do with the actual weight of the soil clay fraction. And the smectite clay mineral, which is the most reactive clay mineral, that's why they use it as absorbents. So like Fuller's earth and bentonite, which are bentonite's used for landfill liners and cat litter because it can absorb a lot of water and is lowly permeable. And Fuller's earth, which is a calcium smectite, is used as an absorbent, so they can absorb a lot of water due to the behavior of the clay mineral. And that is what's responsible for the high plastic and higher water absorption, which also alters the heating and slowing down of the soil warming up. And it has nothing to do with the weight of the soil. And soils with more clay generally have a lower bulk density than soils that are sandy. And smectite, which is the soil material or soil mineral that is responsible for what they're referring to as the heavy term, is actually lighter or equal to the density of quartz, which is what sand is made up of. So a clay soil is not any heavier than a sandy soil, and it's generally actually lighter. So using the term heavy soils means nothing to me. And a heavy soil to me would be a soil that has a particle density of 3.5 5 grams per centimeter cubed, or a soil that's high in iron and aluminum oxides, which have a density somewhere in the 3 gram per centimeter cube range, not a soil that is smectitic and absorbs a lot of water. So if you have any questions about this video, feel free to comment below. And I appreciate your comments, or if you disagree with me. This is all fun, and I just don't care for this term heavy soils, and I'm showing you why I don't care for the term heavy soils.